All right, so I'm going to say something that shouldn't surprise you, but if r of t traces out a line, then I claim that the curvature is 0 for all t. And somehow that makes sense. If you're on a line, there's no curvature. And so there's no excitement. It's just boring, straight riding along. So let's see if we can check that out. Let's see. So if we have a line, our line is given by r of t equals some, let's say, you know what, let's write it like this. Let's write it as r naught plus tv. And so we can use our previous formula, and we can go ahead and we can compute r prime of t, and we get v. R prime of t is v. And so I get that t of t is what? It's r prime v over length of r prime. That's fine, length v. But then here comes the problem, is that t prime of t, this is constant. This is constant. And so t prime is just 0. And so that means that the curvature at any point t is just, oops, I said 0. T prime is the 0 vector, and so the length of the 0 vector is the scalar 0, which is what we got there. So that's the first example. Second example is I want you to imagine with me if you're riding around on a circle, like a circular roller coaster, and you sort of pick a speed and you lock in on this circle, what's the curvature? And hopefully you sort of see the curvature is constant. It's not changing. And so let's see if we can see that as well. So I've picked a circle in 2 space by setting z equal to 0. So this is living in the xy plane like this. And I want us to work out the curvature together. So again, key curvature formula is t prime over r prime, take the length. And so I need to remember that, of course, t of t is r prime of t over length of r prime of t. And so let's begin by computing r prime. R prime of t is going to be minus a sine t, a cosine t 0. I need the length of r prime of t, and this is going to be, well, think with me, it's going to be a squared sine t. We should assume a is positive here because I don't want to have to deal with absolute values. So this is going to work out to a root a squared sine squared t plus a squared cosine squared t, which is just going to be a. So the length of r prime is going to be a. And now I can compute t of t, right? This is going to be what? Minus sine t cosine t, when you, comma 0. When you take r prime and you divide by its length a, then you cancel the a's out. And so now we're here, and I want to go t prime divided by r prime. So I'm going to go back, and I'm going to write this as curvature k of t at any point t is, well, it's going to be minus sine t over a. It's the length of this, minus sine t over a, cosine t over a, 0. The length of that is going to be the square root of what? Sine squared t over a squared plus cosine squared t over a squared. This is just 1 over a. And so the curvature on a circle at any point is 1 over a, and that's really interesting. So a here in this circle is the radius. And so as a, which is our radius, goes to infinity, the curvature goes to 0. And somehow that should make perfect sense. The wider the circle, the less you're going to feel. In fact, when you get a circle big enough, you can't even really feel the curvature. And so that's exactly what's happening. All right, well, at risk of a little bit longer video, I want to show you one more formula. Sometimes I work this out in class, but I'm not going to today. It just turns out that you can prove that the curvature is equal to the length of r prime cross r double prime over the length of r prime cubed. And I encourage you, read the book. The proof is laid out very well there. You can read it and understand it. But we're not going to go over that in the video today, but I do want to work out an example where we use that together. So let's see if we can do it And here's the example that we're going to do, is t squared, t cubed. And so let's begin. If I'm going to use this formula, then I need to find r prime and r double prime. I do want to point out to you that you don't have to. You can always use this formula as well. They're both formulas you're going to need to know. They kind of have advantages and disadvantages. If you've already got r prime and r double prime, you want to use this one. If you've already got your hands on t, you might consider using this one. It just depends on the context and the problem. So here we go. I'm going to compute r prime of t, and I get 1, 2t, and 3t squared. That's r prime. All right. Now I want to compute r double prime of t, and I'm going to get 0 and 2 and 6t. Now I want to compute the cross product of those two. So I'm going to get r prime of t cross r double prime of t, and I'm going to be very careful when I do this. So I'm going to hide this part and do this one minus that one. And so I get 12t squared minus 6t squared. That's the first component, negative parenthesis. Hide this one. 6t squared minus 0. So I'm sorry, it's just 6t. So minus 6t. The last one, we're going to hide these ones, and we just get a 2. So that's that. We end up with what? 6t squared minus 6t comma 2, and we can write this if we want as 2 comma 3t squared minus 3t and 1. So that's that. Next thing I want to do is I want to begin computing lengths. So I need the length of this guy and the length of this guy cubed. And so here we go. So let's see if we can find the length of r prime of t, and we're going to get the square root of, well, 1 squared is 1 plus 4t squared plus 9t to the 4th. That's the length I'm just pulling from right here, plugging it into the length formula. I get that. And so this is the same thing, by the way. I'm going to erase the square root. This is the same thing as saying all of this to the 1/2. And cubing something to the 1/2 is easy because you just cube it and then you multiply 3 times a half and you get 3 halves. So the point, I guess, is, we'll go ahead and write it. The length of r prime cubed is, just going to copy this guy and whoop, put that right there, and then we're going to erase this and we're going to get 3 halves. Okay, so that's that. Very good. Now I want to do the length of this guy, and so right here, and I'm going to say, well, the length of r prime of t cross r double prime of t is going to be, pull that 2 out of the length. You don't need that anymore. It's there, but you can just ignore it and take the length of this and multiply by 2. It's positive, so we're good. So it's going to be 2, and then it's going to be the square root of 9t to the 4th plus 9t squared plus 1. So that's that. And we're there. So now, after all this work, we can figure out what the curvature is. The curvature is this guy. We're going to copy this and pop it in here. And then we're going to divide. And we'll copy, where was, this one. R prime cubed, copy, and put it right there. And that's it. And so the point is, now this is a curvature at any point t. So in particular, if you want to know, like, what's the curvature at 0, then you're going to get what? 2 over 2 times 1 over 1, which is just 2. So the curvature at 0 is 2. And you can plug in any t value you want and work it out. So that's how you can find the curvature function. All right, so let's end this thing here, and then we're going to wrap up hopefully very quickly after this.